This is a University of Lethbridge Department of Mathematics and Computer Science 2610 video by Nicole Wilson. In this video I will explain how to use Logisim for Computer Science 2610. We'll learn how to make objects, how to alter objects, how to connect objects, how to lay it all out, and then I'll discuss some of the important differences between Logisim components and components or gates on the chipsets of chips. There are some related references to this that can be found on Moodle. There's a document there showing all the gates and Logisim that we need to use for gates in our chipset, and then the general lab exercise submission guideline. So in the submission guideline there's a couple of parts that pertain to logic circuits. So in particular, logic circuits that you create must correspond to Boolean expressions, K-maps, truth tables that have come before them, and the wiring diagrams that come after them. Also, every question must have an answer. That means if you've been asked to make a lab circuit or a logic circuit and you don't make one, the question will not get marked. The whole question won't get marked. Every part of it must be done. Okay, so the other document is this one. In this document we have a list of components on the board or chips in our chipset, and then the corresponding Logisim component, including the folder and the name of the component where that exists. Some of these have more pins, so for example here there's a pin right here that we don't use when we use the hex digit display. If you don't have a lead labeled out of it in this list, you shouldn't be touching it. Okay, so let's look at Logisim itself. Logisim can be downloaded for Mac or PC, and we have it installed on the Linux boxes in the lab. To use it in the lab, open up a terminal window and just type Logisim, and it will immediately bring up a window that looks like this. So, how to make objects? Well, the objects that are available to you here, the most commonly used ones can be found in this shortcut menu across the top. And then under various other things we have here. So first thing we usually do is make a switch. So this is a switch. It's a kind of pin. Often we also need LEDs. This is our final output. It's also a type of pin. Both of these can be found here. There's a pin. And then you have to alter it to get this. It's much easier just to use it from the shortcut menu. So anytime we want to create any kind of gate, so suppose we needed a NAND gate here and a second switch, so we're going to NAND two switches together. So there's our two switches. Notice here we have an inverter, we have an AND, and we have an OR, but there isn't actually a NAND gate there. If we go under gates, here's all the other gates available to us, and there's the NAND gate. So we just click on it, and then click where we want it. If you make something you don't want, you can just make sure it's selected, so it's not selected there. Here it is selected, and delete it. Now sometimes these objects are not the way we want them to be, so for example, suppose I wanted these right now. If I click and drag, you can see that the pin coming out of this is facing to the right, or east, and I perhaps would like it to face down. I can alter these by selecting it and then looking at the things I can change here. So one of the things is facing, so I can face it south. I can also change the number of data bits. So right now there's just a 0 there, it's a single digit. I can change it to a double digit or triple or whatever I need. And the only other thing that's significant for what we're doing here is the label. So say I was using X and Y for this particular circuit, I can change the label to X, and it'll appear immediately to the left. I can change where the label is located. I can make it north of it. I can also change the font and size, so I can make it more visible. We can copy these by selecting and then Control-C, Control-V to paste, and you can go in and change the label on your copied one. There we go. So suppose we wanted to NAND some things together and some others, and then OR it all together to get an answer. Okay. I can draw a wire out of the bottom of this and the bottom of this one, just like that. If I select the whole thing when I move it, and the wire moves. If I only select the switch, the wire will not move. So often we need to be doing things with spreadsheets, or not spreadsheets, with truth tables where we are entering both not x's and not y's and x's and y's in. A nice structure for doing this looks like this. So I take a NOT gate and I put it right next to this. Now to create a wire from X to the NOT gate, when I've already got a wire here, I just click on the wire and drag to where I want it. When you're creating wires, you can only put one bend in it per drag, but what I can do is drag it part way and then drag some more. So as long as I let go part way through, I can put those wires exactly where I want them to. This is actually more important than it might seem at first glance, because sometimes if you just let the wires do whatever they will, you end up with them running into other pins, and then your logic circuit won't work at all. So this is a pretty typical setup when we are just translating a truth table to a circuit, usually with something like sum of products. Okay, so now let's connect this all together. Suppose we wanted not x NAND y. So I'm going to take this and hook it up to the not x, and I want to NAND it with y. Now if you look carefully, you'll notice there's actually 5 pins into this. I could go through here and change it, so number of inputs is 5, so I could change it to 2 or 3 or whatever I needed. I could also change it to more if necessary, but the default is 5. That would be really inconvenient if we were constantly needing to change it to 2 or 3, but the fact is that unlike real gates on the chips in Logisim, or the gates in Logisim, if you don't connect something to these pins, it ignores them. It's really important to know that's not the same as it is on the chips. If you have a chip and you've got 3 inputs into an AND gate and you only connect 2 of them, the results will be unpredictable. The problem is that coming into pins on a chip, including the pin for every gate, there's actually 3 states, not 2. Here we only have 2. 0 and 1, but on our actual chips there's 0, 1, and nothing connected, or a null. And so when there's a null, you get unpredictable results. That means each gate you're using on a chip, every input must be connected to something. So here, let's suppose we want to AND x and not y, so I'm going to connect this to x and this to not y, and then I want to OR the 2 of these together. So if I go like this, I can turn, but I don't really want it like that. And if I come out here and do this, I've accidentally hooked up to 3 of them, which is not what I intended. But if I just come out and I do one little bit and then come down and across, I can get that across, down, and across. This isn't crucial, I just wanted to make sure you know how to do it for later on in cases where it does become important. And then we can come across and attach. So one of the other things we might want to alter about these is labels for the rest of the things in here. So for example, this is a very simple circuit, so it's not that big a deal, but I could go in here, change my font to 20, and say I want to say what this is actually connecting. So we're connecting not x and y. To make it a little easier to keep track of things, I could put bracket not x, y, like this. And so now we've labeled that. Now notice this is a little bit too big to fit inside there, so I can just change the font. This one I'm ANDing together x and not, no, just x and y. I said not y, but I didn't do it. Let's fix that. One of the advantages of fixing this is I get to show you how to delete. So I want to get rid of this wire. I literally select it and hit the delete key. And I want to come across now like this. So this one is x and not y. Not c, x. And I'm going to bump this up to say 16. Similarly, I can label this one if I want to. This one turns out to be x naught, y naughted, or x, y naught. And it doesn't fit very well in there. Again, if it really matters to you, you can go through or make it smaller. And we can label our output as well. I'm running out of imagination here, so I'm actually going to call it output. The default position for the output label is to the right or east. For the inputs, it's to the left or west. That's just so that it's the opposite side of the pin. And this is how we make them. Okay. So laying it all out, if you're going to be getting a lot of things coming from your two switches, it's useful to put these vertically and then pull everything across. It's much tidier. If your logic circuit works but the image is so messy that I can't follow, or whoever's marking can't follow it, you'll get 0 for it. We won't even bother trying. So keep it tidy. Now, the other reason we do this on Logisim rather than just drawing pictures is so we can simulate it. Under simulation, simulation must be enabled. It is. If you've got a clock attached, you must enable ticks to watch it run automatically, and you just click on it to make it run manually. And you, instead of the pointer, need to have this hand. So now if I click on the X, it's going to change it. And you can see the color of the wires. You may be able to see change there. So light green means it's a 1, dark green means it's a 0. So you can see dark green coming into the inverter, light green coming out. Plus the numbers show. If you hook things up improperly, you will see other colors. So for example, if we go into wiring, one of the things that isn't in that document I showed you earlier is the splitter. All of these wires have a width of 1. They're sending 1 bit. Sometimes we need to have wider. So in this one, for example, on this side, this has a width of 2, and you can see bit width 2 on the input here. Fan out 2, so there's 2 coming fanned out on the other side. So this is how we can either split or concatenate wires to get thicker or thinner wires. So if I change my fan out, if I change the fan out to say 4, notice 2 of them are gray here. That means they're not doing anything, and the reason they're not doing anything is my bit width in is still 2. So if I change that to 4 as well, now everything's there. It's hard to see, but they're also labeled 0, 1, 2, 3. If we treat this as a 4-bit number, then the most significant digit is this one, the bit 3, and the least significant is the bit 0. So that means if our number was 1010, which is the 2-bit version of 10, it would be this way, 1010, not the other way up. If I now try and connect this over here to this wire, everything turns this orange color, and a 4 appears here, and I see a 1 here in other places. The problem is, this is expecting a 4-bit number, and this is sending a 1-bit number. Those don't match, and so down at the bottom here we get the error incompatible widths. Also, notice this is turned red. That's because we don't have anything sensible to send out, so nothing is being sent out here. There's no longer any information being sent, and that we get an E in here for an error. So most of the errors that you can make doing these will be caught very quickly. That's everything you need to know about Logisim to get started working on your lab exercises.